Hello, good morning, friends. So today we will see one more experiment with related to geotechnical engineering laboratory. I hope you all are fine. I am sharing the screen. I hope it is visible to you. Okay, we are left with two more experiments. So we will see that today. Unconfined compression test. So it is not always possible to conduct the bearing capacity test in the field. Sometimes it is cheaper to take the undisturbed soil sample and the test is strictly laboratory. Also, to choose the best material for the embankment, one has to conduct strength based on the sample selected. Under these conditions, it is easy to perform the unconfined compression test on undisturbed and remolded soil specimen. So, what are the specifications for this test? The test is conducted as per IS 2720 10 1991 methods of test for soils. Part M determination of unconfined compressive strength. 43 soil and foundation engineering. The test is performed on a cylindrical sample with a height to diameter ratio of 2:1. The sample is placed between the plates of a mechanical load frame without any covering or lateral support. Load and deformation readings are noted until the failure of the sample or a strain of 20%, whichever is smaller. So, what are the equipments required for this test? Loading frame of capacity 2 tons with constant rate of movement. What is the least count of the dial gauge attached to the proving ring? Proving ring 0.01 kg sensitivity for soft skills, 0.05 kg for stiff soil. Soil trimmer, frictionless end plates of 75 mm diameter, Perpex plate with silicone grease coating, evaporating dish, aluminum container, soil sample of 75 mm length, dial gauge of 0.01 mm accuracy, balance of capacity 200 gram, and sensitivity to weigh 0.01 gram. Oven thermostatically controlled with interior of non-corroding material to maintain the temperature at the design level. What is the rate and temperature used for the drying of the soil? Sample extractor and split sampler. Dilate sensitivity 0.01 mm. Theory. The unconfined compression test is by far the most popular method of soil shearing strength because it is one of the fastest and cheapest method of measuring shear strength. The method is primarily for saturated cohesive soils recovered from the thin wall sampling tubes. The unconfined compression test is an appropriate for dry sands or crumb clays because the material would fall apart without some land of lateral confinement. In the confinement compression test, we assume that no pore water is lost from the sample during setup or during the shearing process. A saturated sample will thus remain saturated during the test with no change in the sample value, water content, or voice ratio. More significantly, the sample is held together by an effective confining stress that results from negative pore water pressure, generally meniscus forming between particles on the sample surface. Pore surfaces are not measured in an unconfined compression test, consequently. The effective stress is unknown, hence the undrained shear strength measured in an unconfined test is expressed in terms of total stress. Precautions. Both the ends of the sample are shaped so that it should be sit properly on the bottom plate of the loading frame. Rate of loading of the sample should be constant. Procedure. The sample is prepared in the same way as the triaxial test. Its natural water content and dry density are determined prior to testing. The length L0 and diameter D0 are also measured. Set the sample on the pedestal of the equipment. and completely all the necessary adjustment for applying on axial loads. Apply the axial loads at a strain of about 0.5 to 2% per unit per minute and continue the load till the sample fails or the demonstration deformation range reaches 20% of axial strain. Sketch the failure pattern and measure the angle of failure if possible. Take a small sample of soil from I guess there is some technical problem. The screen is not moving. So, confined compression test is one of the most suitable method for determining what you can say. Wait 1 second. I'm trying to resolve this issue. Is it visible to you? Sorry for the inconvenience caused. Okay. I hope it is visible to you. Oh, so the precautions which you need to take are both the ends of the sample are shaped so that it should sit properly on the bottom plate of the loading frame. The rate of loading of the sample should be constant. Procedure. The sample is prepared in same way for a triaxial test. Its natural water content and dry density are determined prior to testing. The length L0 and diameter D0 are also measured. Set the sample on the pedestal of the equipment and complete all the necessary adjustment for applying an axial load. Apply the axial load at a strain of about 0.5 to 2% per minute and continue the load till the sample fails or the deformation reaches 20% of axial strain. Sketch the failure pattern and measure the angle of failure if possible. Take a small sample of soil from the failure zone for water content determination. The axial strength E percentage equal to delta L by L naught into 100, where delta L is change in length of specimen, L naught is initial length of specimen, corrected area is A, capital A equal to A naught, 1 minus something. Now, A naught is equal to initial sectional area of the specimen. C is the compressive stress sigma 1, which is the principal stress, is delta sigma 1 equal to P by A, where P equal to axial load. A plot sigma 1 versus epsilon gives the maximum strength, which is the unconfined compressive strength of the soil specimen. Observation and tabulation. Initial data available. D not equal to dash centimeter, L equal to centimeter, A not equal to centimeter square. Initial bulk density rho T is in gram per centimeter cube. Initial water content W is in percentage. So data sheet for sample is one is this way: strain dial reading delta L in axial strain in percentage, corrected area A in centimeter square, roving ring reading PR, axial load P in kg, stress equal to sigma equal to P by A kg per centimeter square. Plot a graph of compressive stress as ordinate and axial strain as abscissa. So pre-viva question. So what is the difference between unconfined compression test and triaxial test? So there is a big difference. If you study both of them detail, you will understand with the help of procedures. What is meant by unconfined compressive strength of soil? Unconfined compressive strength of soil is nothing but the compression soil strength of soil which is due to unconfined soil sample. Plot roughly a Morse circle and convert compression. So that graph you can plot. Explain the procedure to determine unconfined compression. Procedure you can determine how sensitivity determine using the graph. Average unconfined compressive stress QU is equal to dash kg per centimeter square. Angle of internal friction is this much. Undrained cohesive strength is kg per centimeter square. Verification or validation. Minimum 3 samples should be tested. Correlation can be made between unconfined strength and field SPT value, and practically up to 6% strain the readings may be taken at every minute 30 seconds. Unconfined compressive strength Q equal to this much. Shear strength S is equal to Q over 2. So post viva questions include why we need more circle for this experiment. Next, is there any stress which cannot be determined in the case of unconfined compressive test? Could the drainage condition be handled in the unconfined? Now, one more test which we need to understand is vein shear test. Aim is to determine cohesion of shear strength of soil. Aim of this experiment is to determine aim of this experiment is Aim of this experiment is to determine cohesion or shear strength of soil. The structural strength of soil is basically a problem of shear strength. When shear test is a useful method of measuring the shear strength of clay, it is cheaper and quicker method. The test can also be conducted in the laboratory. The laboratory vein shear test for the measurement of shear strength of cohesive soil is useful for soils of low shear strength, less than 0.3 kg per centimeter square, for which triaxial or unconfined test cannot be performed. The test gives the undrained strength of soil. The undisturbed and remodeled strength obtained are used for evaluating the sensitivity of soil. Specification. The test is conducted as per IS 4434 1978. This test is useful when the soil is soft and its water content is nearer to liquid. So what are the equipment required? Vein shear test apparatus with accessory, soil sample. Theory. The vein shear test apparatus consists of four stainless blades fixed at right angles to each other and firmly attached to a high tensile steel rod. The length of the vein is usually kept equal to towards its overall width. The diameters and length of the stainless steel rod were limited to 2.5 mm, 16 respectively. At this time, the soil fails in shear on a cylindrical surface around the vein. The rotation is usually continued after shearing, and the torque is measured to estimate the remodeled shear strength. Vein shear test can be used as a reliable in situ test for determining the shear strength of soft sensitive clays. The vein may be regarded as a method to be used under the following conditions: where the clay is deep, normally consolidated and sensitive, where only the undrained shear strength is required. It has been found that the vein gives a result similar to that as obtained from unconfined compression test on undisturbed sample. Procedure. A post-hole borer is first employed to bore a hole up to a point just above the required depth. The rod is pushed or driven usually until the veins are embedded at the required depth. At the other end of the rod, just above the surface of the ground, a torsion head is used to apply a horizontal torque, and this is applied at a uniform speed of about 0.1 degree per second until the soil fails, thus generating a cylinder of soil. The area consists of the peripheral surface of the cylinder and the two round heads. The first movement of these areas divided by the applied movement gives the unit shear value. Observation. Force observed P in kg, eccentricity, lever arm x centimeter, turning moment P in kg per centimeter. Length of the vein L in centimeter, radius of the vein blade R in centimeter. Calculations. Undrained shear strength of clay Cu equal to P into 2 per L plus 3 per square. Pre-bio question. Is this method the direct method to determine the shear strength side? Is it possible to determine the sensitivity of clay using this method? What is meant by sensitivity of clay? What are the advantages of vein shear test? What are the disadvantages of vein shear test? Result. Undrained shear strength of clay is U equal to dash kg per centimeter square. Verification or validation. When the strength is greater than able to be measured by the vein, that is, the pointer reaches the maximum value on the dial without the soil sharing, the results will be reported in either of the following two ways. Example 195 plus kPa or less than equal to 195 kPa. The vein shear strength of soil is. Is this experiment an easy one? What is the equation used to find the shear strength? How is the torque applied to the sample? These are the post-value questions. So this apparatus is also not available in our lab, so we'll only. I guess it is struck somewhat. I guess it is struck. Hello, are you able to listen me? Hello, hello students, are you able to listen me? Hello, Hello, students, are you able to listen me? I guess there is a technical issue. The screen is being not shared, so I will just explain you the important topics related to this particular experiment. Hello, are you able to listen me? Just drop a message in the comment box.